I'm a freelance Angular developer or full stack developer, but the Angular specialist. And yeah, I was a bit annoyed about untyped routing, like Angular allowing typos in our navigation. And yeah, I tried to fix that problem. And yeah, more you will see right now. All right. So first, I just want to reiterate on what the problem is, or the problem that I see with the Angular router, or how it can be extended. I call that stringly typed in comparison to strongly typed, if you're a bit of TypeScript nerd. Yeah, the thoughts that I had, the insights, the problem I wanted to solve, the results. So I will show you a demo. We'll jump into some code, the library itself. I show you how it behaves. And after that, just a short thing, how to set it up. It's really easy. Don't worry, this section won't be too long. And then after that, like under the hood, how it works. So really going into the TypeScript types, analyzing how that is made possible. So yeah, stringly typed. The Angular router is really powerful, so I really like it, but it has a problem. It's all just strings. So, like as you can see here, I hope it's big enough. We have our route config, where we define our paths as strings, which is one part of the API of the router. And then on the other hand, we somewhere call that we want to navigate to such page, right? And we do this with router navigate by URL, router navigate, or with router link. And there, this is just strings again, and they are not connected. So it's both just strings. And this can lead to a lot of problems. You can have a typo, page doesn't work anymore, you only detect it at runtime. Now, yeah, what I see how people try to fix this is, oh, sorry. All right, here. So how I see how people try to fix this is they create a routes constant, for example, which they keep in sync with their paths. And then whenever they navigate, they just call this routes dot whatever constant and pass it in there. Now this works, but now you somehow have to kind of keep in sync the route configuration and this constant. And also you cannot really handle params very well with that, or I mean you can create functions, but it just doesn't feel so nice, and it's the second source of truth. Now, what I also saw is that you create a shared constant. So taking it a step further, define your constant, and then also use that constant definition in the routes itself. So instead of writing the path as a string, you now use the properties from the constants as path. Now this brings another problem. Like you can see here the two examples. This is just flat, right? It's just a flat array. But routing, or the Angular router, it's not flat, right? It's a tree structure. And now how do you define that with the constants? It's not really possible, right? You can somehow, I saw some hacks doing it, but then they strip like prefixes. So in the child routes, they would reference the constant and strip the prefixes, but again, not very nice, and no real runtime validation that your code works. So to summarize, the problems that I saw or kept seeing, like every fix to this problem was a second source of truth, or it was very limiting in how you can, for example, define your routes. As I said, you cannot define it as a tree anymore, it's just flat. And yeah, I thought, hey, that can't be it. I don't know if you use Supabase, if you ever used the Supabase client library, or Keasley ORM, for example. They are really great. You can pass them an interface. So you pass an interface of your database schema, and from that, they validate that your SQL queries that you write with strings, that they match your database schema. So really powerful string to or interface to string mapping. And I thought, hey, why can't we do that with the Angular router? I mean, we have all the information there. We have just strings at the paths, so why not derive something from that? And yeah, so I thought, okay, we have the routes array, we do some TypeScript utility type magic, and then we should somehow get the union type of every valid path that's present in our app. And yeah, now I want to show you the result. So yeah, we walk through autocomplete, typos, rename, refactor, everything. So let me set that up. All right. So I created this really small, just demo application. It's just some routing. So we have just our root route on the slash, page 1, page 2. Okay, yeah, page 2 doesn't work. Maybe we have to see why. All right, but then again, yeah, we have page 3, these work, okay, good. Yeah, and then let me swap to the code. I think for that, I will change to the screen duplication or mirroring. All right, and then, so we had the demo app here, just very simple nav and the default works page when you create a new Angular component. Now, page 2 doesn't work. It doesn't work. Now let's see if maybe we find the problem here. So we just have this is just the app. I put everything into app.html. We have our nav bar here. And we see, okay, this is the root link. We have the link to page 1. Okay, I had a typo here. It's page 20 and not page 2. So let's fix that. And okay, now it works. Okay, cool. But it's not so cool that this is possible, if you ask me. And so, yeah, what could we do about that? So I will put page 20 here again, just to show you. And you see right now, I import the router link from the Angular router. But I can come here and grab typed router link from Angular typed router library. And now let's put it in here. And now if I open the terminal and this rebuilds, then I see, oh, okay, there's an error in the template of component app. And it points us to our router link and it says, hey, page 20 is not assignable. Yeah. So let's come here. I think we also see it here, so I don't even have to open the terminal. Now let's come and fix that. All right, squigglies are gone. So yeah, that's basically what the library does. But it can do some more. Now, for example, there's also the router itself, and it works the same there. So we have navigate by URL, and if I change here, we have inject router from Angular itself. If I come here and I grab typed router, the same API, so we don't have to do any additional changes. It's really just the import swap. If I come here and I type some other stuff, we see right away that there are red squigglies and the project won't compile. So other use cases that could be, like if you change a route's path, like usually you have to search for all occurrences of that route. And yeah, if we now use typed router and we change it, just have to find it. Oh, here, app routes. I come here, I say this is page 1 and an additional character. Then now, right away, all references show up as invalid. All right. Now, like this is one part with the strings, but then we also have parameters, right? We can have dynamic segments in our routes. Now, we also have, I also have a solution for that. And now we can come here to the typed router DTS. This is the only additional file you need to set up the library. And what it kind of does, I mean, we go more in detail into that, but what it does is merge or kind of get the types that it needs from you. So we have our user typed routes interface that's coming from the library, and we now override its routes property with the app routes. So this is just the app routes from you, your normal router config. And down here for the route params, so when we define the route param, we say colon, and then we have some name, right? Now, one thing for the library we could have done is just replace colon parameter with string, but I think that's not good enough. So what we came up with is here, we have route param types, and on the left side, the keys, this is your param names. And on the right side, you can define a type that is assignable to those parameters. Now, the first two examples is really just for example, because usually, like if you had home, about, contact, whatever, you would just have it in your routes, right? But where it's really valuable is when you have, for example, an organization ID, a project ID, some kind of ID. Now, and yeah, you can set it here, and then the app itself, whenever there's a dynamic segment, for example, here we have this router navigate. We navigate to /orgs, then org ID, projects, and then it accepts a project ID. If I remove the sorg ID, which is a typecast from string to organization ID, if I remove that, the router won't accept it anymore. So what is that useful for? If you have a function and you have positional arguments, now these are, even if you have like named arguments, but here you have even positional arguments, it's very easy to make a hiccup. Like for example, instead of the organization ID here, we pass the project ID instead of the organization ID and so on. Really, it's really easy, right? And with that feature, we can prevent that and make sure that only the proper parameters can be passed there. So a further type safety net. Now, we achieved that with branded types. I don't know if that's saying something to you, but I will show it afterwards more. Yeah. So one more thing we had to do to make this work is by default, you have your the Angular routes or the router when you create a new, or when you create a new routes file or you have a new app, you have const routes and then colon routes and then equals, and then you define your routes here. Now with the typed router, you don't do that anymore in this way. What you do instead is in the end you pass an asConst satisfies routes. For your developer experience, that's basically exactly the same. With the satisfies parameter, you will still have all the type completion, auto-completion, IntelliSense. And with the asConst, like this is the magic keyword, it will make this array read-only. And so the paths, which were just strings before, are now string literals. So TypeScript now really knows there's a path called page1 instead of it's just path string. So yeah, and that's basically just all changes you need. You create asConst satisfies routes. You set up this typed router type definition file, and you swap the imports from router to typed router and from router link to typed router link. Yeah, nothing more. Then one more thing is then coming to mind, or came to mind to me, is how do you validate that no one is importing from router anymore? Because you don't want to use router import anymore from Angular, right? You want to use typed router. And for that, I have set up ESLint. Oh, this is the wrong file. Here, an ESLint config or a plugin. We can just activate the plugin here with the config, just import from Angular typed router ESLint. And when I come back to the app.ts, we can already see the IDE is screaming at us for importing router and router link. So now we kind of have an end-to-end type-safe routing experience without any runtime wait, because this is all done at compile time, and when we compile it, all the TypeScript types go away. So this has like no performance impact. It's all just all just compile time. All right. I think that's all for the demo. I hope I haven't forgot anything. Otherwise, we switch back later. Now back to the presentation. Okay, so to wrap up, with the typed router, we now have one source of truth. So we just define our routes. We have the small connector, the definition file, where we just import our types. And if we want, we can also assign special types instead of strings for our parameters so that they are type safe as well. And we get auto-completion on every path. Typos become compile errors. The same goes for router link. And I think in general, this is just giving a better refactoring experience. So we can change a route, and suddenly every router, as a route by URL and router link, lights up red instantly. Yeah, so we do one change and we see every broken reference. Where I think this also comes in handy is now with AI, we create, I think, so much more code, and it's very important that we review it very well. And I think with type safety, or having a type safe wrapper around that, is just one way more to make sure that the AI didn't make a mistake that slips past us. And the AI can even, it will see that there's a problem, right? Because it sees the app doesn't compile, it sees the reason, and it can fix it by itself. And yeah, we can also constrain the parameters like that. Yeah, how to set it up? It's actually really simple. You have there's an ng-add command. You can just say ng-add Angular typed router, and it will set up the definition file. And also, there's also a migration, by the way, that transforms your route files that it finds to asconst satisfies routes instead of just colon routes. So we do ng-add, and it registers the typed router definition file in the tsconfig, so that TypeScript can pick that up. We connect our routes, and we swap the imports, done, and we can set up the companion ESLint plugin. So the total overhead for having this typed routing experience is one declaration file, 2 import swaps, and the asconst satisfies routes, and everything else happens automatically. All right, now how does that work under the hood? This will go very deep into TypeScript, so I need a glass of water. Need some hydration for that. So, as I already mentioned before, like the number one ingredient or most important part at first is the asconst satisfies routes, which will make sure that path string becomes path and the actual literals. Second part is the interface augmentation, and what that just means is that you override an interface that the library provides. This is in the definition file that we saw before. And then it goes into the library, where we have kind of this type pipeline from extracting all of the routes, concatenating the paths, replacing the parameters, and then creating this string literals, from that the string union, and command. Command is how Angular calls the tuple that you pass to navigate when you don't pass a string. It's called, this type is called command. All right, now let's go through this pipeline. So at the very root, we somehow have to connect, get the paths from the route, right? And so what we can do is we put in the routes. So this is the routes type, the array that we pass in. And with the extends, so we have routes number, extends infer r, which kind of tells TypeScript, hey, for every possible union, for every entry in the union type, do this down here. What does that mean? So with routes number, we would just have, we have the union type of all the possible routes, right, the entries. And with infer or extends infer r is now just one route, one of those route definitions. And from there we can just go further and say, or we have the next type, extract the route paths from the route. So now we go one level deeper. We were on the array. Now we go down to the route itself. And a route can have 3 branches. So it itself can define a component. It itself defines a path. It has children or can have children, and it can have the load children property. So we have to handle all of those. And then and this is like this union type that does this checking. So in the first branch, this would check the route itself. Now a route can be navigatable or not. So what that means is you have a route, and this can be that it just adds a path to the whole tree, but you can't really navigate to it because it doesn't have a component. So navigating to it is just a 404. And so we have to check that and check if it's navigatable. It's this first type here, but it's a very simple check. It's just checking if it has a component or load component property. And if yes, we go further and we just join the path segments together. So you see it has a prefix property here because this is a recursive type. So it has a prefix, and in the beginning obviously it's empty, and we just take the path itself from the route, add it to the whole thing. And then for the children we kind of do the same. We extract the children or extract the promise from low children and just get their path and put it together. And you see here for the children that they call extract raw paths. That's the function or the type from before. And so this is a recursive type. It just iterates the whole route tree with this distributive conditional and extracts all the paths. Now, I really like this TypeScript feature. It has like string pattern matching. I hope you can probably not see it from back there, right? But so when we now have those paths together, we now have to extract the parameters, right? We have to extract the parameters and replace them with the types that we assigned in the definition file. And we can basically do it like that. You can see it here. This takes a string, so the whole string with colon, the param name in there, and then we can match this pattern of the string. So we first start by inferring the first part of the string. This means, hey, like everything here, just save it. It's just the type, right? But save it in this start type. And then we match the colon. And then we have the parameter name. And after that comes the slash. So that's how we can extract that. We can pattern match for everything before the colon is prefix. Everything in between the colon and the next slash is the param name. And then after that comes the rest. And it's basically the same for all the other chains It's just which, I mean, the param can be at the beginning, it can be at the end and in the middle, right? So that's why there's different statements, but yeah, that's what this is. And then of course also the looking up the proper type for the typed parameter is then as simple as having a lookup on the route parameter types that we had in our definition file. So if you remember, the key was the actual parameter name, and then after that comes the type as a value. And so once we have the parameter name, we can just look up from that map and replace this parameter string with the actual type. Yeah, just a little side note again for the branded types. I said we go into this a bit later. So TypeScript is a structurally typed language. What that means is if two types can have a different name, but if they have the same structure or the same base type, they are assignable to each other. And as I said, for those positional arguments, for example, to validate those, we don't really want that. We don't want that an object, project ID, which is a string, is assignable to an organization ID, which is also a string. In that case, we want nominal typing, that is called. And we can do that with, we can define a type. And then you see here we have a string, and we can define this and then just put a symbol there. So symbol is a TypeScript primitive, or that could just be a key that is unique. And as long as the library doesn't export that, others cannot use that, so that's really internal. And we just define some value. And now user ID is not, or a string is not assignable to user ID anymore. And when we get, for example, data from the API, we just typecast, right then when we get the data, we just typecast the user ID from the string that it was, we just cast it to type user ID, and everything works as before, but now it's really its own type. Yeah. Same we did before for the actual paths, we also do for the commands. So yeah, same pattern matching, but then instead of just putting it into a string, we put it into an array. Now, this is the entire runtime edition of the library. So we just have we define the class typed router, which extends the Angular router. And then instead of here having navigate commands, which was an any array in the base router, now becomes the commands type from the library. And navigate by URL now takes path, which is the type the library defines with each, with the union type of the valid paths that are there. And yeah, same goes for the router link. So and in the end, it's just calling the original method. So actually, there's no real, yeah. So yeah, we're at the end of the journey, kind of. So we started at the stringly typed router. We have no real connection in between. Well, we can do it better. And the Angular typed router library is like one solution to this problem that we could use. It's really simple to set up, and you now even know how it works under the hood. And yeah, the repo is obviously public, and you could also implement it yourself or wizard your own solution. What's really important for me is that it has 0 runtime cost. So with no overhead, we don't generate some code. It's really just types. It's a drop-in replacement, so it has the exact same API. And I think that's really great developer experience. Like, yeah, that's how I want to have it. I don't want to change everything from normal setup. Do you have any questions? Yeah?
It's ready.
People here can stream.
Okay, thank you. You mentioned earlier that Angular is not supporting these types or building a type because it's not a good solution. Why is this one not categorized as a good solution, but just look at nice?
I mean, that was just an assumption, but yeah, as I said before, I think like the Angular router, with the Angular router you can also unregister or register routes at runtime, which would make inferring types impossible, right? Because it's at runtime. And I could imagine that as the framework offers, they have to provide a solution that works in all cases. And so I could imagine that's the reason why we don't have a typed router experience right now in Angular. Yeah, because there are some, actually I forgot to say that, sorry, good thing you asked that. There's one major trade-off, I think there's one trade-off to this approach, is that usually you can also pass a relative to parameter, right? So that you navigate relative to another route. And currently we don't support that. So you have to always provide absolute URLs. Yeah. Yes.
Other questions?
Yes.
Yes, a question regarding the special TypeScript syntax. Can you go a few?
Yeah, sure.
I'm not sure how you called it.
The string one, or?
Yes, I think something similar. The extends, and then it looks very similar to a template string, and I'm wondering if it's useful to think of it as a template string, or if it's better to think of it as a TypeScript feature. Would you recommend one way or the other to thinking about backtick?
Yeah.
Start to end backtick, because I'm not. Yeah, I'm.
No, I think I would think of it as a TypeScript feature, because I mean, right here in this use case, it's really about you pattern match against the whole string, and you take out parts of it and rearrange them, all at the type level. So yeah, I would think of it as a TypeScript feature. Yeah.
Any more questions?
With the library, the URLs, like the path names, they become type safe, but query parameters don't yet. Do you consider adding them as well?
I mean, that's an interesting idea, but I think with query params, it kind of can come everything, right? So the user can put anything in there. So you can't be sure really, but it's always type string somehow. So we could probably add that somehow. What is your use case?
Like we frequently have the use case like putting selected products into the URL for multi-edit or multi-something. And then those would be untyped, like the path would be typed, but not the IDs you can or cannot have there.
Okay. I think we'll have to think longer about that. But I mean, I'm really glad if you open an issue, if you see like a missing feature, or you can connect with me and we can see what we can do. Yeah, I'm sure we can come up with a solution, or I hope so at least. Yeah.
Anyone else got some questions? All right. One from Andreas. Here you go.
You mentioned there is a public GitHub repo. Is it also published to NPM?
Yes, it's published to NPM. It's called Angular-types-router. You will see it in a slide or two. Yeah? Okay, yes, you can just use npm install Angular typed router or ng add if you don't want to do the setup by yourself. Yeah. Yes? At work we have some kind of cube that we can throw that has a microphone in.
It's a question about the versions of Angulars. Which version are you? So the npm package you have from which Angular version is it possible to use?
So the pre-release version was for Angular 20, and now it's for Angular 21. But like if you have an agent project, now if you don't have that yet, I mean, the code is, I think it would support all Angular versions, like all late Angular versions, probably until 16 or 15, as far as I know. So you could probably even force install and it would just work. Yeah.
Thank you.
Someone else? All right. Oh,
All right.
go.
Yeah. So, we have. Okay.
Yeah,
all right.
one more question. Did you measure how much the type checking takes longer with your library enabled?
No, actually, I haven't. So I'm using it in my own projects, obviously, and I haven't seen any performance impact. But measuring it would be definitely interesting. Yeah, and I think like with I'm also looking forward to TS Go, which then everything will become way more fast anyway again. Yeah.
All right, sweet. Then if there's no more questions, I guess we can move on to the break.
Yeah, just sorry.
I'm sorry, it's my first time moderating. Big mistake. Sorry, guys.
1 second. So yeah, if you want to connect with me, this takes you to my LinkedIn. Please message me if you have any question about the library or some feedback or additions, open issues. Really glad if you want to use it and see it. Other than that, if you're ever in Lucerne, we are organizing JavaScript Lucerne every now and then, so you could stop by if ever you're there. And yeah, if you're just interested in Angular in general, I have I think 2 other interesting repos. One is Angular Pixie.js. I don't know if you know Angular Free. It's a custom renderer for Angular that instead of rendering to the DOM, creates 2D objects on the canvas with Angular code for Pixie.js. Really cool project. And Angular Image Optimizer, which does, ng optimized image. And then you can have a loader, which goes to a remote and loads an image in a specific format. The library will create on build time, will create different versions of your image and then use that instead. So you don't have to use a CDN, you can just generate the optimized or there's multiple versions at build time. And yeah, that's my GitHub /Dominic Bachmann. And I also built this small app, Resume Creator. So if you're looking for a job and you need to write a resume, you can have codes from me to use it for free. Yeah, thank you very much.